Okay, I have started the recording. Okay. Anyone has this calculator?
Yes, sir.
Okay, fine. So, fine. And how about this? This calculator, anybody owns?
Sir.
Okay, so what I
Yes,
will
sir.
do, I will teach you how to operate both the calculators. All right. So first I'll start with this particular calculator. Is it fine?
Yes, sir.
Okay, fine. Now, um, keep ready your equations. The first problem, the three loop network we took, right? Yesterday's problem. Determine I1, I2, and I3 for the circuit shown below. Yeah. So that network, you keep it ready. All right. And then what you do is press the mode button here. Wait, let me start from the beginning. Turn on. All right. And then press this mode button here. Okay. You don't have to unmute your mic because that will it will create confusion. Okay. So you can one of you, let's say Adya. Okay. I will give a pause. Okay. After each step.
Yes,
If you
sir.
are able to follow, Adya, you just keep typing yes or no. Okay, in the chat
Yes,
box.
sir. So, but your screen is a little blurred, sir.
It's blur.
Yeah, a bit.
Okay, now is it fine?
Yeah, yes, sir.
Okay. Even the slightest hand movement, it picks it as a signal, and that's the reason that distortion. Okay,
Yes.
all right, fine. My colleague is helping me out. Fine then.
Okay.
So simultaneous equations are ready in your book, right? Now let me use option 5. So option 5 is meant for equation, right? In your screen, in the LCD display, you can see that next to 5, there is equation, correct? So that means to say the selection key should be selected. Okay, and that selection key is number 5. So press number 5. Done. The moment when you press the selection key, you will be given with the further 4 options, right? The first option says some ax plus by is equal to c. That's the reason we had kept our equation something like that. IR1 plus IR2 is equal to E1, right? Now, in the problem what we discussed other day, we had 3 unknowns, right? So in equation, or sorry, in the selection button 2, you can see that you have a 3 variable equation. Ax plus by plus cz is equal to dn. So do selection number 2. Okay, press switch to this one. All right. The moment you press that, you will get a matrix. You can see that it's a square matrix. And you can see the columns A, B, C. That means to say the corresponding coefficients have to be entered in. Okay, so let me start from the first equation. Okay, so the first equation is um, what is it? Can you tell me what is the
minus
coefficient
8.
of right? Yeah. So in the meantime, one person can help me out with the coefficient. Type -8. Okay, there is a minus sign, right? Ah, okay, and then press equal. So -8 appears in your first element. Is it
Yes,
appearing?
sir.
That's all. Then
Yes.
you have to go on feeding the values. Okay. What is the second coefficient?
Plus
3.
3.
Okay, 3. I'll enter. Press equal. So you can see that uh, the matrix has an element 3. Okay, and C is 0, right?
Yes, sir.
Okay. Then finally D. So D is your EMF. What was your EMF? 15, right? Or
Yes,
minus
sir.
15?
Minus 15.
Okay, write down -15. And once again, press equal. So now it has come to the second row. So do the same thing in the second row. Okay, what is the first coefficient?
3
3.
Okay,
Minus
minus
9.
9,
-9 is it?
Yes, sir.
2
And
Okay,
plus 2.
okay. And -10?
minus 15.
-15 is it? Okay, enter. Done. Now third equation, you tell me. 0,
0,
right? Hmm.
2 minus
Plus
10,
10? Okay, -10, -10.
35.
Oh, sorry, -10. I have to go. Okay, so that's -10. Okay, and how much is it?
35
-35.
plus
35?
35.
Okay, plus 35. Fine. Press equal. Okay, and then hit one more equal. Okay, it gives the value. Okay, x is equal to, so x corresponds to I1, y corresponds to I2, and z corresponds to I3. Okay, so this is in fraction, right? So you can always press this S to D. Okay, it gives you in digits. So just press this. So current is 2.55 amperes. Okay, so X is equal to I1 is equal to 2.55 amperes. Then press equal button once again. Okay, 1 minute. Yeah, the video is, there is some lag. Okay, there is some lag in the video. Okay, I'm going to keep fluctuating.
నా పేరే
It
చెప్పి
keeps
కనిపిస్తుంది
fluctuating. This
చెప్పమని
happens.
చెప్పినాడు అందుకే చేస్తాను.
Okay, so why? How much did you get? Can anyone tell me in fraction
Sir,
how much
lagged, sir.
did you
Network
get?
lag.
Yeah, sir. It's little lagging.
Not taking. Well, signal is signal is low. You know? Okay, there was too much,
So for fraction, what we have to press, sir?
uh, you were able to follow?
Yes, sir. For fraction, you said something, sir.
Okay, you were able to follow that particular calculator operation?
Yes, sir.
Okay, I'm sorry about the lower bandwidth. Okay.
Sir, that was FX 991 ES plus, right?
That was, yeah, FX 991 ES. I'll just
Yeah,
type
it
it.
is different compared to 991 EX FX.
EX, right? I will tell you. I will tell you orally. Okay, if
Yeah.
not, I thought bandwidth may support my explanation.
Yes,
Okay,
sir.
that's the reason. But no worries. Okay, so I have typed in the chat box. So 991 ES is done. Okay, so those who have 991 ES, you guys don't have any doubts, right? How to operate the calculator.
So for decimals, what we have to press?
S to D, there is a button just below cos button. There is a button S to D. Able to get it?
Yes, sir.
Okay. You could get it in decimal.
Yes, sir.
Okay. Yeah. So that button we have to use. Let me try once again from my colleague's phone. Okay. If I'm able to show you the 991 EX. Have you joined the class? Yeah. Yeah. Are you able to? Are you able to? Okay, you're able to see the
Yes, sir.
calculator? Okay. So this
Yes,
is
sir.
Yes, sir.
FX 991 EX. Okay. So not bad. Okay. There's a mode button next to power button, right?
Yes, sir.
Press the mode button. You'll have set of options, right? Yeah, there is lag, right?
So you can turn on video in one account and audio in another account.
Gives too much of feedback. It takes microphone, right? It takes feedback. Okay, no worries. What I will do, I will tell you orally. Okay, if you're not able to follow, I will shoot a video and I'll post it in a group. That is the only one option. Okay, no worries. Fine. So what you do, I'll tell very slowly and I will write the steps in the chat box. Okay. So step one, this is for 991 EX model. Okay. So step one is press mode. Others, please don't comment in the chat box or else the steps will be lost. Okay. Done. One of you can tell me orally. Say, Hardik, you tell me. Okay. Then keep scrolling right. Okay. You have those navigation
sir.
key, right? Use those navigation key to keep on moving right. Okay. Until you reach to a destination called equation bar function. Are you there? Okay.
Yes, sir.
This is where you are supposed to go by keep on pressing that right key. Okay. Now A is for the selection. Okay. So just above STO button, just above STO button in red color, can you see A letter?
Yes, sir.
That you are supposed to enable. So press A.
So where's that button? A?
Okay. So that button A is just above STO button.
I'm not able to
Above,
find.
yeah,
Above?
above number 7 button,
Okay, yes, sir. Yeah.
there is STO button. And above that, you have a A button.
Okay, sir. Found it. Yeah, thanks.
Then, did you press?
Yes, sir.
Yes, sir.
Now you will have these two options, right? In step 4, one for simultaneous equation,
Yes, sir.
correct?
Yes,
Yes,
sir.
sir.
And 2 for polynomial. So that means to say you can even solve a polynomial. Okay. Now, what is that we are handling presently? We are handling a set of simultaneous equations, right?
Yes, sir.
So press 1. Press 1. Did you do that?
Yes, sir.
Yes.
Now it is asking number of unknowns, right? See, this is the advantage of this particular calculator, that it can handle even a 4-variable equation. Okay, whereas the previous one can handle at the max 3-variable equations, but you'll not get any 4-variable equations in the exam. Okay, fine. So simultaneous equation you have selected, and number of unknowns it is asking. So type 3, because we have 3 unknowns in our system. So did you press?
Yes, sir.
Yes, sir.
Now what is that you are seeing there? You're seeing a matrix, right?
Yes, sir. With
Yes,
X,
sir.
Y, and Z.
Exactly. X, Y, Z are the variables, and against all coefficients you have 0 entries over there. Okay, so keep typing the coefficients, or keep keying in the coefficients. Okay, so keep entering the coefficients of X, comma Y, and Z variables. Okay. So what's the first coefficient? It is -8, correct?
Sir, yesterday
sir.
there was another problem also, sir. We could do that. That 55 I will minus 25 I do.
Wait, now I'm talking about this, right? Let me just finish this one.
Okay, sir.
So, Hardik, what's the coefficient? It's -8 plus 3.
Minus 8, 3, 0.
Yeah, 30, and EMF is -50.
Minus 50.
Okay. And the second equation, it is 3
Minus
minus
2. 2 minus 15.
the second equation is 3, 9, no?
So
Sir,
3 minus 9 and plus 2.
Yes, sir.
Yeah. And that is -50.
50.
Yeah. And third equation is
0.
0 plus 2 minus 10.
Okay, thank you. And 35 plus 30.
35. Yes, sir.
Yes, sir.
Once you are done, press equal button. Again, you will get the answer in terms of X by Y form. Use S to D button to convert it to fraction. Okay, so X is 2.55. y is 1.822, and z is negative 1875 divided by 598 you will get. Press yes to D button to convert it to a number. So minus 3.13. You're getting it?
Yes, sir.
Yes, sir.
Okay. Yeah, okay, Hardik, Ashish, thank you. Fine. Now, what you do, you try to solve the yesterday's problem. Okay. So I will share my OneNote screen so that you will be able to see those equations. A window. Yeah. Is it visible? Yeah. It is visible, right?
Yes, sir.
Yeah, Hardik, you were saying something, no? Now you tell me.
Sir, yesterday you had given a problem, so you just given the equations. We could solve that. That's what I was telling.
Okay. This is the one, is it?
Yes, sir.
Okay. So can you key in those equations now and can we check the answers?
Yes, sir.
Okay. Either you can enter all green equations or you can enter all orange equations. Okay, it doesn't matter.
So I1 is 7.02 amps.
Yeah, let me just write it down on the screen.
Okay, sir. Yes, sir.
Hold on. I didn't connect my tab. I thought I could tell you the live working of calculator. So, there was some lag in the network. Okay, fine. So yeah, let me select the white one. So I1, right? How much is it?
So I'm getting I1 as 7.02 amps.
Let's write it down. Let others.
I2 is 5.314 and I3 12.68.
Amperes.
Yes, sir.
So how about others?
I got the same answer.
Okay. Others can type the answers in the chat box. Okay, are you able to use the calculator?
Yes, sir.
Okay, yes, no, you can type because if you are opening up, if you are not saying anything, that's the reason. You can just let me know. Okay, don't worry. Don't worry about what if I type no and people may laugh at me. Don't worry about it. Okay. What I can do is I can create an offline video and I can post it. So don't worry about it. Okay. Yes, no, you can just type it in the chat box. because I see that 51 have joined, but only 5, 6 have said, okay, I can see one, no problem. I'll make a video. Pin Sumit. Okay, don't worry. Even for one no, I will make a video. Okay, great, fine. So let us solve some more problems. Okay, my OneNote is little troubling me. So okay, can you see white screen?
Yes, sir.
Yes, sir.
OneNote is troubling me, so I'm doing it in PowerPoint. All right, so please take down the question. Yeah, this is a little tricky question. Write down in the circuit shown below. In a circuit shown below, what is the voltage? What is the voltage across CD? Across CD, if switch yes is open and switch yes is closed. Okay, so there are two circuit conditions. One with with yes in open position and one with yes in closed position. Okay, so this is the circuit. So this is, say, they themselves have given, okay, the nodes AB, and this is CD. This is 1 ohm, 2 ohm, 20 volts, and this is our switch. This is switch yes. Okay, it assumes only two positions, either open position or in closed position. It stays. Okay. Presently, it is kept in open position. This is the polarity sense in which voltages are measured, upper side positive and lower side negative. Okay, the supply voltage is given as 120 volt. And the voltage across, okay, EF is given as 100 volt. Okay, it is nothing but, there's a battery between node B and A. There's a battery between node E and EF. Okay, fine. Okay, so first let us consider case A. Case A. So in case A, let us imagine that S is open. Okay, let us imagine that S is open because they are given, right? S is open. All right. So
between C and D resistance values.
So when you open the switch, okay, when you open the switch, let me just write it here. Okay, so case A I will handle with blue color, and case B I'll handle with different color. When you open the switch, will there be any current flow through the switch?
No, sir.
No. So let me say I is equal to 0. And let me write here I through switch S is 0. Okay. If so, the connection can be removed. If so, connection can be removed. Okay. So connection as in the switch connection. The switch connection can be removed. Why to keep loose wires when there is no current flow? Okay, when you do that, this is what your circuit looks like. Okay, what I will do, I'll just take it as a battery. Upper side positive, lower side negative. This is 120, and same thing I will do it here also. Upper side positive and lower side negative. The potential is 100 volts. This is 1 ohm and this is 20 volt. 2 ohm. Okay, the central resistance I have not given, right? This is 10 ohm. This is 10. Okay. So you can solve this problem. Let's say I take mesh analysis. Since we have already studied mesh analysis, let's just apply mesh analysis. Say this is I1, say this is I2. Okay. Write on the equation. Mesh 1. Okay, mesh 1 minus 120. I'm applying in clockwise. Okay, apply in clockwise direction. Okay, so what is it? 120 minus 2I1 minus 10 I1 minus I2 is equal to 0. Okay, or when you simplify this, please check. You should get 12 I1, sum of the resistors, minus the mutual resistance into the current I2 is equal to 120. Okay, so that's my first equation. Then I will apply KVL in mesh 2. Again, I will write apply in clockwise direction. So what do I get? I get minus 10 I2 minus I1 minus I2 minus 20 minus 100 is equal to 0. Okay, so that gives me minus 10 I1 plus 11I2 is equal to minus 120. That's my equation 2. Is it correct? Are you getting this?
Yes, sir.
Okay. Once you get these two simultaneous equations, can I go to next page?
Yes.
All right. So solving equation 1 and 2 gives the mesh current I1. Okay, what's the mesh current I1? 3. Yeah, 3.75. I2 have got the same answer. And I2, is it minus
Minus 7.5.
minus 7.5 amperes? Okay. Now, what you have found is the mesh currents, I1 and I2. But what is that you are supposed to find? You are supposed to find voltage across the nodes C and D, or in short, you can call it as VCD. So VCD is how much? So what is VCD? VCD is basically current into the resistance. Okay. Now, what is this current? Through 10 ohm resistor, which current flows? Ten ohm resistor.
I1 minus I2.
Yeah, 10 ohm is what you say. Mutual, right?
Yeah.
And yeah, it's a mutual element which is present between the first loop as well as the second loop. Okay, so you can take the difference of two currents. Okay, as you said, I1 minus I2, you can do that. Or even if you take I2 minus I1, will the magnitude going to change if you take I2 minus I1?
No, sir.
No, so don't worry about the sign. Okay, you should get the magnitude right. Okay, so VCD is equal to I1 minus I2. So I1 is 3.75 minus I2, so minus of minus 7.5. Okay, into 10 ohm. Right, so this becomes plus, right? So how much you will get?
112.5.
So it is basically 11.25 into 10, that is 112.5 volts. 5 volts. Okay, fine. So that's your VCD. Okay, in bracket here I will write, even you can take I2 minus I1. Okay, fine. So that's your first case. Is it understood?
Yes, sir.
Okay. So case B, when AC is closed. Okay, fine. So when the switch is closed, what is the circuit condition? Okay, those who have understood the question, you please keep solving. Okay, what I'll do, I'll create that phenomenon in the circuit. I'll show you how the short circuit is going to affect the behavior of the circuit. The switch is closed, that means to say there is a least resistance path present across 1 ohm and 20 volt battery. Okay, this is 100 volt plus minus, this is 120. Okay. Okay, let's say I use green color. Okay, now can anyone tell me what is happening here? See, earlier there was no connection across 1 ohm and 20-volt battery, right? The moment when you close switch yes, there exists a short circuit across this 1 ohm resistor and 20-volt battery. Now, whenever there is short circuit, what happens to the current flow? Will there be any current flow through the upper path?
No, sir.
No, what do you say? The short circuit phenomenon. Okay, what it does is it bypasses the entire current through this downward path. Okay, so current is max in the downward path. On the other hand, in the upper path, the current is zero. That's because the current always prefers the least resistance path. And the least resistance path is this downward path. Okay, so I will write this one as least resistance path. Least resistance path. Okay, so experimentally, how can you check? If you can connect an ammeter here, if you place an ammeter here, you will come to know that the ammeter reading is zero. That means to say the current has not flown through the straight path. Instead, it has taken the bottom path. Okay, if that is the case, for what good use we will have to retain the upper path. So you can remove the upper path because there is no current flow. Okay, so you can simply remove the upper path. When you remove the upper path, the equivalent circuit looks like this. Let me redraw the circuit. So there is no upper path, so only lower path is present. And this is your battery, 100 volt. And this is the other battery, 120 volt, 2 ohm, and 10 ohm. Okay. Done?
Sir, I have a doubt, sir.
Tell me.
Why can't we consider this to be another loop, sir?
You can consider, you try to find out which one, this loop, the central loop.
Yes, sir.
But there is no current flow in the upper path.
But sir, technically there will be a current flow, no, sir, even
No.
if it's very less.
No. See, that's the reason, right? That's the reason. See, at home, if there is any unintentional short circuit takes place, what will happen? The current will not flow through the instrument. The current will flow through the fuse element, and the fuse gets blown off. Okay, that's because the current chooses the least resistance path. No, that's the reason. No, your MCB and all trips.
Oh, okay.
If that wasn't the reason, then your instrument would have gone for a toss, right? If there were to be a current flow through the instrument. So when there is short circuit, okay, that's the reason I said. See, that can be experimentally determined by connecting an ammeter in series with 1 ohm resistor and 20 volts battery. Okay, and if you create a short circuit, current flow through this ammeter is zero. Okay, and the moment you turn on the circuit, right, the current gets bypassed through the lower path. It will not take the upper path. Okay, so from the physical observation, we have arrived at this particular conclusion that in case of short circuit, current is maximum. However, the voltage across the device is zero. Okay. On the other hand, in case of open circuit, current is zero, but there will be a voltage across the appliance. Okay. So you don't have to take it as a separate loop over here. Because
Okay.
now you tell me what is the voltage across C and D? Do you have to apply mesh analysis? So it's something like I am connecting a voltmeter here. Okay, just if you connect a voltmeter here, or if you connect a voltmeter here, will it matter? It's the same, right? Because there is no resistance here. So what I can do is that, so that per path I can simply connect with a straight line. So what is the reading of the voltmeter? Can anyone tell me? Connecting the voltmeter across C.
100.
Yeah, or connecting the voltmeter across, let's say, EF is the same, because potential of C is equal to potential of E, because there is no resistor connected in between. Similarly, potential at D is equal to potential at F, because there is no resistor connected. So directly you can write VCD is equal to 100 volt. Okay, you don't have to calculate it. Okay, using observation only, you can say that it is 100 volt. Okay, so this is how you can solve this particular problem.
Sir, what is the effect of 120 volt battery on CD, sir?
Which one? The 120, see, I'll tell you. There is one battery here and there's one battery here. If you want, you can apply mesh analysis and you can find out I1 minus I2. Okay.
Okay, sir.
That also you can do. Okay. Alternatively, you can try out at home. Okay. Homework. Alternatively, you can use mesh analysis. Mesh analysis. Okay. Even if you apply mesh analysis, this 10 volt resistor, now it is always getting connected across 100 volt battery in case B. So whatever you apply, the method, the voltage across 10 ohm resistor remains 100 volt. You can cross check with mesh analysis. Okay. Fine. Okay, fine. One more problem I'll solve. Do we have time? Oh no, there's no time. So the problem what I wanted to solve, I will just give it as a homework, okay? I'll just take a snap and I will post it in your C-section group. You can try out this particular problem. Okay, very interesting one. Okay, all right. So I will end today's session. Okay, probably I will conduct one more class. Okay, do you have class on Monday? Yes, you have a class on Monday. Yeah. So Monday, I'm going to keep a test. Okay. And the portion is DC circuits, Ohm's law, Kirchhoff laws, and the related problems. Okay. So I may not give the problem what I have solved in the class. I may give something else. Okay. But it will be in line with the class problem itself. Okay. Fine then. Is it fine? Monday?
Yes.
Yes, sir.
Okay. All right then. So see you on Monday.
Thank you, sir.
Yeah. Thank you.